All right, today we're going to be doing the focus directrix property of conics. And remember, we have parabolas, ellipses, and hyperbolas. So parabolas are the only conic section that we've already mentioned directrices for. And if you recall, in order for a point to be on a parabola, it has to have equal distance to the focus as well as to the directrix. So that point could be your vertex, right? We know that the vertex is equidistant to the focus and the line that's outside the parabola called the directrix. We know that distance is p. But if I just have some random point on my parabola, this distance to the focus should be equal to the distance, the perpendicular distance to the line. Okay, so the ratio of the distance from any point to the focus and any point to the directrix should be equal to 1 if these two distances are equal. So your eccentricity is always going to be equal to 1. All right, for an ellipse, now we talked about ellipses, but we never talked about actually having a directrix. So we've mentioned that, I'll draw a diagram here. If we have an ellipse, let's say it has a center at the origin. Remember, I have two foci. If I have any point on that ellipse, let's say this point, the distance from focal point 1 and the distance to focal point 2, these two distances should add up to 2a, which is the length of my major axis. All right, so these are two new formulas for you to know. All right, the distance from any point to the first focus is going to be equal to a plus ex. Well, a is half the length of the major axis, right? It's also in this equation, there's our eccentricity equation, c over a. And we know that c squared is equal to a squared minus b squared. Right? This will be new as well. All right, focus 2, the length from the second focus to the point, is going to be a minus e times x. All right, now actually, if you notice, you add these two equations together. This is the distance to the first focus, the distance to the second focus, and if you add this up, the ex parts cancel out, and that adds up to 2a. So that is related to your definition of an ellipse. All right, so these things we already know, but this is a new one. So my directrices, that's the plural for the directrix, is going to be on the outside of my ellipse. So they're going to be over here. This distance is going to be a over e, so this equation is a vertical line. It's x equals a over e, and this distance will be, or this equation is x equals negative a over e. Okay, so that's why it's plus or minus, because you have two of them. All right, now that's going to happen if your major axis is along the x direction. Right, so the larger number is under x squared. And in this case, we're assuming that our center of our ellipse is 0, 0. You could just shift this whole thing over, left, right, up, or down, depending on if your center moves. All right, but then your directrices won't just be opposites of each other. All right, or if your, let's say your major axis were along the y's, then you'd have horizontal directrices. So that's going to be y equals, because it's horizontal lines, equals plus or minus a over e. That's if the larger number is under the y squared term. All right, now if you find your eccentricity for an ellipse, it's always going to be a number between 0 and 1. Okay, if there's too many notes here, just pause it and then come back to the video when you're ready. All right, for a hyperbola, you should already know the definition of a hyperbola. That's the absolute value of the difference of the distances between the first focus and a point and the second focus and a point is going to be equal to 2 times, now it's not called the major axis, but it's your transverse axis. Right, so it's equal to 2a. So that was your definition. The only thing that's going to be different is now we can draw in directrices. All right, so let's say that we have a hyperbola that opens, in this case, right and left. We'll assume our center is at 0, 0. So if I have a hyperbola that looks like this, pretend that they're symmetric there, my directrices are going to be actually on the inside of my hyperbola. So this one will be at x equals positive a over e. This one will be at x equals negative a over e. And the eccentricity of the hyperbola is always going to be greater than 1. So a couple things to point out. Remember that a hyperbola, it's c squared equals a squared plus b squared. For an ellipse, it's c squared equals a squared minus b squared. I believe that in your book there is a typo. If you look at 11.6, yeah, 11.6, the box on page 871, right here, it should say c squared equals a squared plus b squared. This is for hyperbolas. So just in case you're reading the sample boxes. All right, so we're just going to do a couple of examples. Most of these problems do not ask you to graph. They just ask you to find either the equation of the directrices or just what is the distance from the first focal point to a point and the second focal point to a point. All right, so we're going to do number 3, 9, 11, and 13. All right, so problem number 3 gives you an equation of an ellipse and it asks you, it says, given an ellipse and a point P on the ellipse, find F1 to P and also find F2 to P, which is the lengths of the focal radii. That's what these two distances are. All right, so the equation of the ellipse that they give you is x squared over 15 squared plus y squared over 5 squared equals 1. And the point that they give you is 9, 4. Now, if you want to draw a diagram, you can. You don't have to. All right, this is an ellipse that is at 0, 0, the center. It goes 15 in the x direction and 5 in the y direction. Here's your ellipse. All right, so it's longer horizontally. The point 9, 4 is somewhere, should be on your ellipse. Okay, so from that point, we're going to find the distance to each focus. Now, if you really want to, you could actually find where your foci are and do the distance formula, but you can also just use the equation a plus ex and a minus ex. So the point is to use these new equations. All right, so recall that a is the larger number on the denominator, so we know that a in this case is going to be 15. So that's easy. We do need to know e. That's always going to be c over a. So remember, for an ellipse, it's c squared equals a squared minus b squared. All right, so we have 15 squared minus 5 squared. And the answer is not 10 squared, so I actually do the work. It's 225 minus 25. That's 200. So c is equal to radical 200. All right, now if I substitute that in my formula, e equals root 200 over 15. Now, root 200 can be simplified, so let's change that to 10 root 2 over 15, which is 10 over 15, and that's 2/3. So 2 root 2 over 3. Okay, so that I'm going to now substitute in my formula. I have 15 plus e, which is 2 root 2, 3, times my x-coordinate. My x-coordinate is 9. Okay, so that's going to give me 18 over 3, which is 6 root 2. And that's the distance from this point to my first focal point. All right, and then this one is going to be the same thing, except it's a minus e times x. All right, so it's going to be 15 minus 6 root 2. Now, recall, if we were to add these together, you could check. This should be the length of my major axis, right? All right, so that is all they ask you for this problem. All right, problem number 9. This time they say that you have an ellipse and also a hyperbola. So 25x squared plus 36y squared equals 900. That's an ellipse. And I have a hyperbola, which is almost the same equation. All right, so recall that normally in our equations we have it equal to 1, so we want to divide by 900. And then we're going to reduce our fractions. All right, so you're going to get x squared over 36 plus y squared over 25 equals 1, and here it's just the same thing except it's subtraction. All right, so we're going to do the two problems like concurrently, I guess. So you see them side by side. So what's the difference? Now this problem asks you to find where are the foci, what's the eccentricity, and then also what are the equations of the directrices. I feel like that's hard to say, directrices, because I'm so used to saying just directrix, but it's like matrix, matrices. All right, so I know that my vertex or my center would be at 0, 0, right? And my foci should move along the x-axis. This is a squared, so we're going to move along like, not my foci. So, sorry, my foci I need to figure out. C squared is a squared minus b squared. So this is 36 minus 25, which is 11. So c squared is equal to 11. So c is going to be root 11. So my foci are going to be, instead of being at 0, 0, it's going to be at 0 plus or minus whatever my c value is, comma 0. So it's going to be root 11, comma 0, and negative root 11, comma 0. So those are my foci. All right, I'll use a different color for the hyperbola one. All right, the only difference here is that you're going to do c squared equals a squared plus b squared, like the Pythagorean theorem. So this time we're going to do 36 plus 25. That gives us 61. And c is root 61. But I'm still going to go along, not my major axis this time, but my transverse axis. So we're going to move from 0, 0 to 0 plus root 61. And 0 minus root 61, comma 0. Okay, so there's your first answer. All right, my eccentricity is always going to be, oops, sorry, trying to use green here, c over a. So in this case, we've got root 11 over a, not 36, but just 6. In this one, we're going to use c over a as well, but this time c is root 61 over a, which is 6. All right, now remember, we said that the eccentricity should be between 0 and 1 for our ellipse, and should be always greater than 1 for our hyperbola. So just as a reminder, checks out. All right, and then our directrices are going to be vertical lines because we're going along the x-axis. We're moving, so we're going to have lines that go up and down. All right, so these equations are plus or minus a over e. Sorry, trying to switch colors is difficult here. Okay, so I need to figure out a is 6. E is root 11 over 6. Right. Now I'm going to simplify this a little bit, so I'm going to multiply by the reciprocal. Okay, so I have plus or minus 36 over root 11. If I rationalize it, it's plus or minus 36 root 11 over 11. And these are vertical lines, so it's x equals. Pretty much the same, oops, sorry about that. Pretty much the same thing here, except you're going to do, it's plus or minus 6 is a, and e is root 61 over 6. So I'm going to multiply by the reciprocal. That's going to give me 36 over root 61. And if I rationalize it, I'm going to get 36 root 61 over 61. And that's x equals again. Now this should be plus or minus because there's 2 of those. And then we're all done for number 9. All right, number 11 and 13 are like working backwards problems. Okay, so number 11 says, use the given information to write the equation of an ellipse. In the end, they don't want the equation equal to 1. They want it to be in this format. So it tells you that the foci are at plus or minus 1, 0, and the directrices are at x equals plus or minus 4. All right, so think about what this means. If my foci are at 1, 0 and negative 1, 0, then that needs to be along my major axis. I know that my ellipse is going to be longer horizontally than it is vertically. Okay, so I know that I have to be in the format x squared over a squared plus y squared over b squared equals 1. So the larger number has to be under the x. All right, I know also my center is at 0, 0. All right, my equation of my directrices is always going to be a over e, which I know is 4, negative 4. Right? So I can solve this equation. I'm going to ignore the plus or minuses for now. And I'm going to rewrite it a little bit. So I know that I can say a equals 4e, and e would be equal to a over 4. So we're going to come back to that in a second. Which I know that the eccentricity is always c over a. Okay. But now I got too many variables here, right? So I know the ratio of the eccentricity is a over 4, which should be my generic equation is c over a. So we're going to solve this, but I have a's and c's. So how can you find c? Well, for an ellipse, I'm always going to use c squared equals a squared minus b squared. So do I know anything? This gives me one of those letters. Remember, foci tells me c. So 1 squared equals oh, I can solve this now, so let's do that. If I solve this now, this one, all right, a squared equals 4c, right? We know that c, here we go, is equal to 1, so 4 times 1. So a squared is equal to 4, which means that a must be 2. Okay, so now we know this. A is 2, and now from here you could solve for b. All right, so 1 minus 4 is negative 3 equals negative b squared, so b squared equals 3. All right, well, you can figure out b is root 3, but we really want it to be in this format. So we got a squared, so that's 2 squared. Here we got y squared over root 3 squared, which is just 3. All right, and then I don't want to leave it like this. This would be fine normally, but because they wanted it in this form, we need to multiply by something. So 4 and 3 go into 12, so I'm going to multiply by 12. So this gives me 3x squared plus 4y squared equals 12. All right, final problem. Number 13, kind of the same thing, except it says write the equation of a hyperbola, and they want it in the format ax squared minus by squared equals c. So the fact that this x squared term is positive tells you that it's going to open to the right and left. Okay, and the information they give you is that the foci are located at plus or minus 2, 0, and the directrices are x equals plus or minus 1. All right, so what do we know about our focal points? We know that this gives me c, so c is 2. Okay. My directrices are always going to be x equals a over e. Right now, we know that equals 1. So a must be equal to e in order for that ratio to be equal to 1. My eccentricity is always c over a. So I could use these two equations and say that a equals c over a. Do we know anything else? Well, we know c is 2, right? So a equals 2 over a, and if I multiply, I get a squared equals 2. So that's helpful. In my equation for my hyperbola, I know we're going to do that. I've got a squared is 2, so I know that there's a 2 underneath my x squared term. I don't know b squared yet, so I'm going to come back to that. But that's where you're going to use your c equation. Right? So for a hyperbola, it's c squared equals a squared plus b squared, just like the Pythagorean theorem, right? So we've got 2 squared equals 2, right, plus b squared. So we got 4 minus 2, b squared is equal to 2, and then that's this number. So we can just put that in here. All right, now this would be our answer, except they didn't want it in that format, so we got to multiply by 2. So we're going to get x squared plus y squared equals, oh, that's a minus, sorry, hyperbola. Yeah, x squared minus y squared is equal to 2. And that's your hyperbola equation. All right, if you have any questions, write that down and then ask questions in class tomorrow.